about data warehousing. Yeah, so I'm actually borrowing the slides from Scene, and yeah, this was a 2021 presentation as far back as then. And I know that, yeah, for most folks over here, whenever they think of lakehouse, the first thing that comes to their mind is, oh, you have to use databricks. It's most likely databricks and all of that. But what would happen today is that I will be showing us how we can effectively implement a lakehouse solution without even using the Databricks platform. It's more or less like we are trying to implement the open source Databricks environment. But we'll be using Databricks technologies, but we won't be using the Databricks platform actually. Yeah, so who am I? I am Temilola. I'm a data engineer at Microsoft. What's my day-to-day like? My day-to-day just involves building data pipelines, and apart from building data pipelines, monitoring data pipelines, and also sometimes, yeah, I get to do a few bits of machine learning also, but the machine learning is like 0%, yeah. Data visualization, I don't do data visualization at all. As funny as this might sound, I don't know Power BI. Yeah, I'm happy to say I don't know Power BI, even though I work for Microsoft. I don't know Power BI. I'm not so good at Microsoft Excel. There are a ton of Microsoft tools that I don't really know at all. The Power Platform tools, I'm not so good. Yeah, but for some folks, yeah, they will be extremely good with it. And that's because it's a bit out of my context, and I just majorly take my time to focus on those things that are vitally important to me. And before Microsoft, where was I? I was at Parallel Score. I do consulting for a few as at then. I was working in Parallel Score and doing a few consulting. 2 years ago, I started my career officially with Optive Analytics as a graduate trainee then. And since then, it's been a roller coaster. I think, yeah, let me just use my LinkedIn profile to just walk you guys through who I am, and that way it makes more sense for people to connect easily, and you will know how my journey is like in the data space. I'm not so much of a 10 years of experience kind of person or 20 years of experience kind of person. Maybe Jennifer is though. Yeah. Yeah. So, okay. Yep. So I'll share my screen. Yeah. So, yeah. Got it. Yeah. So I'm sharing my LinkedIn profile now. And yeah, I'll just walk you guys through each of my, yeah. So yeah, I was done. Yeah, just a quick story about me. I was done with school as far back as 2019, and I started working officially in year 2020. Though before school, I did a couple of things. There was a time I was a mobile developer. That I was developing Android apps, writing code in Java and all of that during school days. And in 2020, I joined Optive Analytics, and that was it for me. That was my first major data role, working as a data scientist for 5 months, then going on to become a data engineer. And for me at Optive, you get to work on a variety of projects, and that was it. I left Optive Analytics after a year, joined Babangona as an enterprise systems engineer. I was still a graduate intern because I was at 2021 then. I haven't done my NYC yet. So I literally don't tell companies that I've not done my NYC, except sometimes I tell them, just to let them know, oh, I've not done my NYC yet. So what do you have on the table for me and all of that? Then after 6 to 7 months, I left Babangona. I joined Parallel Score. Yeah, there are a few other work experiences that you wouldn't see here, like that came in through freelancing, consulting, and working on other projects. And in May last year, I joined Microsoft officially. So that's how it has been for me. And the major tools that I've used in the past and I still use currently, right from 2018, 2017, when I started doing data team, has just been majorly Python, SQL, Spark, SQL, PySpark, and all of that. Yeah, so that's all about me. Yeah, I used to be a certificate freak. I know I have close to maybe 40 to 50 certifications then year on LinkedIn. I've stopped, I've banked my boots. I don't have my boots, but this year I'm picking it up, and yeah, I'm going back. I'm going in hard again this year, hoping to do more. Yeah, and yeah, that's all about me, and let's go straight into it. I don't know if someone has a question about my experience, or yeah, that's the little story about me. I'm trying to see that's certain. Oh, thank you for saying all of that. Oh, okay, it's good. Thank you for listening to me too. And I'm sharing my screen in a bit. There we go. So here's how it's going to work, guys. I will take us through the theory section. Yeah, I'll let us know what lakehouse is and tell us a few things. Yeah. Yeah, don't worry, I'll come back to the question. Yeah, so I'll take us through the whole lakehouse concept, and after that, we'll just have a workshop where we build a simple lakehouse. It will just develop a Spark ETL pipeline without how we can do that without affecting production data, how we can perform all sorts of best software engineering practices in implementing a lakehouse. Yep. So I assume you can all see my screen. And yeah, I'm not here to talk about databricks. Yeah, so we all know what databricks is, and yeah, we'll start. So if you look at it, as far back as 2010, the early days, many problems with data analytics today stems from complex data architecture, complex data modeling, and all of that. But right now, what a ton of folks, even at Microsoft, Netflix, Airbnb, what we all do today is we try to implement, we've moved from the Lambda architecture to the Lakehouse architecture. So Lakehouse technologies, what it does is that it removes all those complexity. It brings in the data warehousing, streaming and ML directly on a data lake storage. So it's more or less like what we're doing is we are abstracting compute from storage. So we know that storage is cheap now and compute is quite expensive. The normal data warehouse architecture that we have in time past has been that we have compute and storage together. But right now we're trying to like have our storage in one part, and from our compute we can always query our storage whenever we need to. And that way it helps the company to reduce cost and all of that. The biggest challenges have always been data quality, staleness, and all of that. Yeah. So yeah, a few surveys done by Filtran, Cargo, and all of that. So I'll just walk us through the data, the evolution of data management. I'm going to share, yeah, for whoever is asking about the slides, I'm going to share the slides with Jennifer. She'll send it in our mail newsletter. Yeah, so like I said, as far back as 1980s, we had the data warehouses where you could only work with structured data. We're all used to the old ETL thing. And until recently, when people started doing the ELT thing through the analytics engineering concepts that we now have recently. And yeah, if you look at it, what are the problems we have with data warehouse? We can't have, it doesn't support unstructured data, and it also doesn't support semi-structured data like time series, logs, images, documents, and so on. I remember I said earlier that there was high cost of storing large data sets. Why? Because we're using compute to store data, so it doesn't really make so much sense. And also support for data science and ML was very minimal, not so great actually. And if you look at data lakes, yeah, for data lakes, yeah, we had low cost storage, ETL jobs, and all of that. If you look at how we've come, we've had data lakes, we have had data warehouses, and now we're having lakehouse. So if I'm to put it to us out there, I'm going to just put it this way. The combination of your data lake, the combination of your data lake and the data warehouse is what actually gives us the lakehouse. So I'm trying to rush through the slides so we would all see what a lakehouse really is. So what's the problem with today's data lake? Yes, data reliability suffers, multiple storage systems with different semantics. Most times you hear that a data lake becomes a data swamp, that it becomes swampy in the sense that all those ACID-based transactions you can do in the data warehouse, it's not available with your data lakes. All of the querying of data in form of a structured format from the data warehouse. You can't get that in the data lake. So it's pretty much that way. And same thing goes for the data warehouse also. And if you look at most of all these problems, the way we are solving it now, it's the implementation of a lakehouse. Yeah. So, okay. Yeah, I am looking for a slide that explains this better. So yeah, let's look at this now. So what is the lakehouse vision? We want a system whereby we can have both batch processing, streaming, and we can have structured, semi-structured, and unstructured data all in one place, doing all of our BI, doing all of our data science, and doing all of our machine learning, all in just one architecture, all in just one system. It's a single platform for every use case, and it has all of the management features from transactions to versioning. Yeah, I'll be showing us a very nice tool that help us. Yeah, I'll be showing us the Git of big data. So the same way we have GitHub, Bitbucket, all those version control systems for our software engineering processes. We also have the Git of data environment also. I'll be showing us that too, and I'll be showing us how we can do versioning for a lakehouse and how things can work in isolation without having to copy data from one place to another, without even messing up data in production systems. And yes, we are good to go. Okay. So yes, what are the key technologies enabling the lakehouse? Like I said, the storage layer, you can perform transactions, versioning, and more. You have new query engines, you have optimized access for data science and ML, in the sense that you have a lot of people working on data and they are not messing up the data. They're literally working on this data without having to copy this data, without having to create duplicates of this data. And it's easier for you to implement data governance with a lakehouse system, actually. Okay, now here comes the icing of the cake. You can't implement a lakehouse without a file system. Apart from a file system, without a specific technology. So this whole lakehouse buzz started when we started having systems like Iceberg, the Delta Lake, and the Hive. And this day, in today's world, if you want to implement a lakehouse, you either want to do that using either Iceberg or Delta Lake. So what it does is that you're saving files in a structured and also in an unstructured format in your data lake. So a data lake normally is for collection of files. But with Delta Lake and Icebergs, you can query these files as if they are tables. So it's like saying select star from so file, and you're able to query it as if it's table. And whenever you perform operations on these files, you can perform what we call time travel for these files, meaning you can query the first version of the data, you can query the second version of the data, you can query the third version of the data. Why? Because for every operation you perform on the data or on these files or on these delta tables, it stores all these operations in the metadata layer. So in actual sense, it's like saying, oh, the metadata is where we store all the information about the data itself. So, okay, I'm trying to beat time so I can take more questions. So like I said, to implement the lakehouse, you either want to use Delta Lake, Iceberg, or maybe the Hive metadata store. But the easiest way to do it is to do it with an open source technology called Delta Lake. And it means we'll be saving our data in different formats. So there are two major formats that you'll be saving your data, which is the Delta table format and Delta live table format. So the Delta live table supports structure streaming. You don't have to start writing you have to start creating your messaging and queuing systems with Kafka and all of that. It's like you just do it out under the hood straight up for you. I am going to show us that also. And what else? Yeah, I think the next thing for me to do now is show us a simple architecture that abstracts all of this and passes the concepts well. Okay. Okay, I'm going to share my screen in a moment and show us something that explains it. Okay. Mm. Okay, I found what I'm looking for. Okay, perfect. Yeah. So I'm going to share my screen now. Okay. Yeah, so here it is, guys. This is what I meant by having a lakehouse. Yeah, to implement a lakehouse, like I said, you want to be working with either of the different file formats that are available, the file format technologies that are available, either the Iceberg, Delta Lake, or yeah, if you want to write from scratch, you can use the Hive Meta Store and create your own from scratch. So the lakehouse architecture works in such a way that we have 3 stages of the lakehouse architecture. We have the bronze layer, which is where we have data ingested in its raw format. I remember what I said, for the lakehouse, you can have streaming and batch processing. You can have streaming sources, you can have batch sources, all coming into the same system, into the bronze layer where we have the raw tables. Then we now have the silver layer, which is where we have refined tables, where we've done some sort of transformation and some cleaning. And we can now have the gold layer, which is where we have much more refined tables, the aggregated data store, which is where we have different data mats, where we've done a lot of data that is meant for HR, data that is meant for operations, data that is meant for logistics, and you implement a lakehouse on top of a cloud object store, on top of a cloud object storage. So what does this mean? If I want to implement a lakehouse today, what do I need? I need a cloud object storage. I can use the Hadoop file system. I can use Azure Data Lake Storage. I can use the Amazon S3 bucket. I can use the Google Cloud Storage System. All I just need is any of the object storage. Why am I doing this? That's because these things are cheap. You can store large amounts of data on these things, and these things scale easily. You can store large amounts of data on these things, on these solutions, and you're not going to pay so much for it compared to when you're storing it in a data warehouse or in a big data warehouse like maybe Redshift, Snowflake, and all of that. So number one, you are cutting costs, and number two, you are abstracting your compute. Yeah, so the normal cost whereby you would have been paying for maybe the Redshift compute instance and all those things, or Snowflake and the rest. All those compute costs that you get normally for your typical data warehouse, it's no longer there anymore. So you're only paying for just storage. Then when you need to query your data, you just go to any computer you're using to connect. It can be local, it can be a server, it can be a K8, a Kubernetes cluster, anyone, and you query your data directly. But the best way to make sure that your lakehouse doesn't become a swarm is using the Delta Lake table format. Okay, so I'm going to show us, this is the typical databricks lakehouse architecture, and I'm going to show us a similar open source way of implementing the lakehouse. So I don't know if we can all see this. Okay. Yeah. So this is a use case here where I was trying to implement. This is a use case where I'm implementing a lakehouse architecture for an healthcare organization or an healthcare consulting firm. So what's happening here is that, like I said, we would have all our different data sources. You can see here on my left, I have the primary data sources, which are the different healthcare providers, insurance companies, and the rest. Then we have the CMS data, which is the external source. And what I have here in this box. So I want you guys to look at this rectangle here as this X3 bucket. So what's happening here is that this bucket here is this rectangle here. I am only putting this rectangle here to explain the different layers of the lakehouse. So like I said, we have the bronze layer, the silver layer, the gold layer. And if you are coming from your left, you'll see that from all of the different data sources, I'm using different tools to bring in data from different sources. It can be Spark, Python, it can be even maybe using an RPA to web scrape the data from somewhere and land it into the S3 bucket. So I wanted to see the different layers as different folders in an S3 bucket. I can have the bronze folder, the silver folder, and the gold layer. All these things are just folders, actually. So what we're referring to layers are just different folders. To some people, they can, I know a lot of people relate more if you say, oh, we have the bronze schema, the silver schema, the gold schema. Yeah, I don't know if you want to take it down. And for this open source lakehouse implementation, like I said, I am using Delta Lake to implement the lakehouse, and I am using another tool called LakeFS to bring Git versioning to the data environment. So what this means is that we have the same data in the bronze layer. Let's say a data scientist wants to work on this data now. He creates a new branch. Once he creates a new branch, he has access to this data. He performs all of his data operations on this data without having to leave the data from one place to another place. And by the time he's done, he creates a PR to merge all of his operations into production. Then the senior data engineer comes in, goes through all what he has done and approves the PR. Then all those changes are being merged into production. But remember what I said, the data is not leaving the S3 bucket. The data is just in one single place and different people are working on the same data. So if you look at this architecture here, from the bronze layer, perform some sorts of transformation, take it to the silver layer, and from silver layer, we're taking it to the gold layer, and we're now taking it a step further. So yeah, for some folks, they still want to have their data in a typical data warehouse where their backend guys or the software developers, application guys can connect to this data directly to feed on whatsoever solution they are providing. So that's why we have a PostgreSQL data warehouse here for this particular use case. And from Postgres, we are connecting to Neo4j to build a knowledge graph. And they have this web application and mobile application where they are rendering knowledge graphs on the front end. Yeah, I don't know if we've heard of knowledge graphs before. Yeah. So one more thing I also want to point us to is that for this architecture, all of the workflow orchestration is being done with Airflow. For some folks, they might want to use Darkstar, they might want to use Prefect, or they might want to use the one that is currently making the buzz and data source, which is Mage. And to implement LakeFS, like I said, LakeFS is just adding an extra layer of Git version into your data environment. So all of the old metadata of creating branches, creating commits for your data, pushing your data from the dev environment to production, all those information is being stored in the LakeFS login store, which is most times a Postgres cluster or Yugabytes database. I don't know if we've heard of Yugabytes before. Yeah, so Yugabytes is more or less like a cluster of databases. It can be MySQL, it can be the Postgres variant. So yeah, if you don't know some of all these tools, yeah, just write them down. And yeah, we'll talk more about them later. Okay. And I'm just going to show us this last architecture to show us something much more grand, whereby you can see data in different formats. Yeah, in extreme formats. So this particular architecture I'm showing us here is what a friend of mine or one boss I work with will refer to as the lake of fire. Yeah, so lake of fire in the sense that, let me put that in the chat section. Yes, so, okay. So lake of fire spelled as, okay. Okay, so I don't know why this is messing up. Yeah, Norma, go on with your question.
Good morning. It's not a question. I can no longer see your screen. I don't know if it's just me
Yeah, I stopped
or your
sharing my
internet is
screen.
still sharing. Okay.
Yeah, I wanted to type something. Jennifer, I'll just send it to you. You can help me type it in the chat section. I'm unable to access the chat. Yeah. Yeah. So Lake of Fire spelled as that. Yeah. So Jennifer is gonna help me put it in the chat section. Okay. No, this okay, yeah. Yeah, so I guess you would have put it by now. So this is what it refers to as the lake of fire architecture. So if you look at the health space, the standard that they are coming to right now in the health space all over the world is you want to have a standard whereby your health data in Nigeria here can also be used in the US, in the UK, in Spain, in Portugal, wherever you find yourself. So the standard that guides processing of health data is what referred to as FHIR. That's FHIR, is what referred to as FIRE. And they have a lot of standards, a lot of rules, a lot of things you must follow when processing health data and all of that. So this lake of fire here is also a lakehouse architecture. If you look at the data sources here, what this my boss is trying to achieve here is that it wants a lakehouse architecture whereby it can get data on DNA and RNA sequencing. It can even get proteins concept, push it into the system, IoT data, social media or web data, user data, claims and insurance data, and the clinical data itself, which is the fire data itself. That's the electrical health records data itself. So both structured and unstructured data is feeding it into the system using Fire, using Kafka, and all sorts of technologies. And like I said, you can't implement a lakehouse if you don't have the 3 stages of the lakehouse: the bronze layer, the silver layer, and the gold layer. And if you notice what I did here, the rectangle always represents the storage buckets. Yeah, the storage bucket is the lakehouse itself. Normally, for most folks, they believe, oh, this is a data lake, but this is different from a data lake because we are going to be saving data using the Delta Lake table format. That's Delta tables and Delta Live tables. You can read more on these technologies too. Can read more on these technologies, and you get to see a ton of technologies here. Is using Smolder to move some fire data. Is also using Glow, and Apache Spark comes in, LakeFS for Git versioning of the big data environment, and all of that, API 6 for security gateways. And another cool thing about Delta Lake is you can implement Delta sharing protocol. So what this means is that people are able to query the large amount of data you have using APIs, and it's extremely fast. They don't have to copy the data. It's more or less like they're reading directly from the table itself. So there's what we refer to as Delta sharing. There are a ton of capabilities with Delta Lake. You can read more on it. And yes, like I said, for this particular lake of fire architecture, is using Gigabyte DB gateway. That's the clusters of DB to undo the LakeFS logging. So I think I've said so much about the lakehouse. And at this point, I think I'm going to pause to take a few questions before we go into the practical part of things. Yeah, okay. I can see one question in chat section. It says, how would you say Azure Databricks differs from the open source Databricks? Yeah, so it differs because you're not using the Databricks platform for the open source Databricks. So all you're just doing is it's a cloud agnostic implementation of the Lakehouse or Databricks platform. What it means is that I can have my storage buckets in AWS. I can be using the AWS S3 bucket, and I can have my compute instance in maybe Google Cloud or Azure Cloud, and yet I'm still able to implement the whole lakehouse. Then I can script the whole infrastructure using Terraforms and just deploy automatically. Yep. So I've answered the question. Oluwashino has another question. You might want to, feel free.
Okay, good morning. So my question is, what's the difference, like this lake house, what's the difference between it and a data lake? Because I'm actually used to like data lake, but this, I don't know, is there a difference between both of them?
Yes, so there are a ton of differences. The very first difference is that, number one, it's easy for a data lake to become a data swamp. Why? Because you have to do all of the file and folder structure organization yourself. And number two, a lake house is different from a data lake. Why? Because you'll be saving data in a specific file format. It can be Delta table format or the iceberg format. And this means that you are saving the data itself, and you're also saving metadata of the data itself. So let's say you're saving data as the Delta table in the lakehouse. You are saving the data itself, which can be a package file. Then you also have a JSON file where you're storing all the metadata operations about the data itself. And for a lakehouse, you can do time traveling. You can query the first version of the data in the lakehouse. Maybe you have a CSV file now or a package file. You can query the first version and you can query second version, third version, all of that. You can do all of that in the lakehouse. And number 3, you can write structured queries directly against data in your lakehouse, which you won't easily do in a data lake. Number 4, there is asset transaction enforcement. There's asset transaction enforcement. There's asset-based transaction enforcement in your lakehouse. All those atomicity, consistency, and all of that. You can get it in the lakehouse, but you won't get that in the data lake. So in the data lake, you are majorly just storing all forms of data, but you are not enforcing most of all those rules. Yeah, interesting. You have something to say?
Yeah, because I actually had the same question as Shina. So from what you are saying, all the logs, right, would be used to like make sense more of that data, right? Because I'm almost through with the Udacity data engineering nano degree, right? And what we use is the music data and the logs. They are stored in like a JSON format. So what you're saying is the lakehouse, the architecture does that for us, so there's more consistency. I just want to understand that what you're saying.
Yeah, exactly. Yeah, exactly. There's more consistency, and I am going to show us a few samples here also. Yeah, there's more consistency actually. Okay, so I'll be dropping a link in the chat section. Yeah, and I'll be sharing my screen in a moment. So I want us to do the same thing to, yep. So it's a code along section. Yeah. There's the chat section. Yeah. Any other question? I guess this is the time to take more questions too.
Hello, Temi. Yeah. You mentioned earlier. Yeah, you mentioned earlier there's some certificates you want to do later this year. Are you going to write a blog and the resources you use so we can follow you in real time, almost real time, so that if we want to do some of those certificates too, we can know the resources you used?
I would really love to write a blog, but I don't know how to write. I'm not so good. Like, probably I'm still trying to pick that up, but I'll be happy to do that actually. Trust me, I'll be happy to do that. Yep. So, yeah, so someone says, what are the regulations one needs to know or be aware of when building infrastructure for health organization? Okay, apart from the GDPR, you also need to understand fire, like I said. You need to understand a lot about fire. And number 3, you would also need to understand the use case or the business where the organization is. What level of data is the organization? What are they going to be handling? Are they going to be handling patient data, or is it just insurance and claims data? You get. So that will speak to the kind of infrastructure or architecture you want to build out for the health organization. Okay. Query performance, agile optimizations is super fast. Trust me, it's super fast compared to the normal data wealth. Yes. So okay. Yeah. Someone said HIPA2. Yeah, cool. Let me share my screen now and let's get into it. So guys, I believe we all have Docker installed, and this code or walkthrough section is actually to put us through a major technology that I use in implementing the lakehouse, which is LakeFS, and also Delta Lake if time permits. So the first, part of this workshop is I want to teach us how to develop Spark ETL pipelines with no risks against production data. So meaning if I have 5 to 10 data engineers or data scientists working on the same data, how is it that, yes, they're able to work without affecting data that is in production? Yeah, all those stuff that I said, data scientists won't create a branch, data engineer to create his own branch. They're all working on the same data without copying data away from anywhere. And by the time they are done, they just create a PR to merge their branch into production and effect those changes on production data. So we are going to start with that. I believe you can all see my screen. And let's have Docker running. Okay. Yeah. So I dropped a link on chat section. I dropped some instructions. So I'm going to be pasting it for us to just follow through. So what I want to do is I want to clone a Git repo. And to do that, is there anyone here who is not comfortable with using the command prompt? Okay, so I'm going to clone it into the document. So I'm going into the documents folder. Okay, I'm going to make a new directory called workshop. Let's all make a new directory called workshop. Up on not too fast though. I will cd into workshop. So right now I'm inside the workshop folder and I'm going to clone the Git repo. Yeah, so I pasted it in chat section. So let's just clone that repo. And that should take some time. We'll do the Docker image and we'll jump straight into it. Yeah. I can also use this time to answer a few questions while that is going on. Okay, it's done cloning the repo. And now the next thing we want to do is, yes, after cloning the repo, we want to build the Docker image and run all of the stuff. So yep. We are in, and the next thing is I need to paste this for us in chat section also. So what's going to happen is the Docker image size is around 4.5 gig. The Docker container file is around 4.5 gig. It's going to download and run the Docker container that includes Python, Spark, Jupyter Notebook, all the necessary JDK we need to run PySpark with Delta, Hadoop binaries, LakeFS Python client, Airflow. Yeah, so it's going to do all of that for us. Oh, that's going to take some time. I should have just added it to the newsletter or mail that Jennifer was sharing. Where's the chat section? Oh, can I zoom in? Yeah, so that's what we're running next. Docker build, LakeFS Spark Python demo. Okay. This is going to depend a lot on our data. Yep. So let me take more questions while that is happening in the background. Has anyone asked any question again? No. Feel free to raise up your hand if you have questions. Yeah, apart from just the workshop, yeah, any question in data engineering, I believe, yeah. If I can't answer the question, my Oga will answer it for me. She's the best. I learn from best. Ubong, you want to say something? Okay, any question? I know you have seen some things like I said gigabyte, I said RPA, I said a lot of things, yeah. You want me to show the architecture? I said knowledge graph, yeah. Is anyone that these things look still pretty much very new to? Like you're just hearing a lot of things for the first time. Oh, wow.
Yes, me, sorry.
Yes, me.
Yes.
Yeah, for me
Yes.
as well. So I'm just taking time to process a lot.
Okay, I was about to say we have wow. Oh, I'm so sorry, even though it looks very, very fast. I'm so sorry. I'm so sorry. Yeah, that's why it's being recorded, and you can watch it again. You can reach out, yeah, to me or Jennifer, yeah, if you need to. Oh, just learned about fire, and fire is spelled as FHIR. FHIR. Yeah. Okay. Wow, 4.5 gig. It's going to take a lot of time. Yeah, we still have an extra hour now. So yeah, it should be done. I'm so sorry. Like if I knew it would be like this, I would have just told us to load the Docker image before running it. Okay. Oh, resend all links. Yeah, sure. I resend all links. Actually, there are no links. They are just commands for you to. Oh, thank you very much, Shidozie. Yeah, Temilola. Yeah, speak up.
Okay. I want to ask concerning that gigabyte DB. Is it like all those massively parallel processing and database kind of stuff?
Yes, it's just a cluster of database that you can run. So instead of just using the usual database or data warehouse, just to make room for fault tolerance and all those things, to make sure that yes, there's no connection timeout, it's not breaking or stopping. Yeah, people just like to use a lot of database in parallel, doing the same thing. Yeah, you can read more on it. Just Google search gigabytes and you need to read more on it. Yeah, there's also the likes of Cockroach DB. I don't know if you've heard of Cockroach DB before. Yeah, there's also that too. And it's somewhat similar. Let me check for others I know of. Yeah, yeah, Cockroach DB is also does something similar to. Yeah. Let me type in chat section so you know how to search for it. Cockroach DB. So the likes of Gigabyte and rest are what some of these big tech companies are using under the hood internally. But yeah, they're not going to say it or tell you. Yeah, so the Docker container image is quite large. It's 4.5 gig. And I'm sorry if someone's data subscription is going to run out while trying to set it up.
Temi, hi. So while that is going on, I just wanted to find out if like anyone had general questions, because like the awkward silences are weird. So does anyone have general questions, basically?
Okay, I guess they don't have questions. Well, it's not nice.
So, sorry, I have a question. Good morning. Can you hear me?
Yeah,
I can
go
hear
on.
you.
Okay, so like, I have a couple of friends that got into analytics engineering, which I'm planning to dive into. So like, and they said like I'll have a plus if I have like quite a few knowledge about data engineering. So I've not even like done anything related to data. This is my first um like introduction into it. So like, do you have like resources on how I can, resources I can take on how I can just dive into it and start learning? So because this looks too much for me like right now. So do you get my question?
Yeah, sure. Jennifer, okay, let me just take that. I created a roadmap one time. Yeah. The only thing I know I missed in the roadmap was I forgot to add terraforms to it. Let me fetch it. Let me fetch the link for you. I forgot to add terraforms to it. And I am going to open it also. Unfortunately, I don't know how we'll share the architecture about it. Someone's work now. I won't be able to share it. Let me open the roadmap and also talk about the roadmap. So that way. Yep. Yeah, so I dropped the link to the roadmap in the chat section. And yeah, let me just quickly talk about the roadmap that I created. And yeah, I'll allow Jennifer make some inputs. And so in terms of data engineering roadmap, I believe the first thing you would want to understand is, yeah, it's always good to start with SQL. SQL is pretty beginners friendly now. So it's just like the normal English language thing whereby you're like, oh, I need data for so. Select the data and give it to me. So there's DBMS part. You should understand database management systems, understand SQL. Once you're done with those two, then you go hands-on. For the hands-on, you use HackerRank to practice most of the SQL questions on HackerRank. Then after that, one more thing you can do that I didn't add here is if you want to go from the beginners level to somewhat intermediate and advanced level, you can try out the Dynamas SQL challenge also just to get busy. Then after that, you go to Python, hands-on, Linux. Then once you're done with all those basic prerequisites, you can now start with everything data. You understand all of the big buzzwords in the data engineering space: data lake, data mart, data fabric, data mesh, data catalog, lakehouse, delta lake, a ton of stuff, data quality practices and the rest. Then once you're done, you can now move on to distributed systems. You have added links to reasonable resources that you find useful. Then you can now go to cloud, consider a few certifications, maybe as a data engineer. I work for Microsoft, so as a first now. As a data engineer, AWS solutions like that, AWS big data specialty, GCP professional data engineer. Yeah, it's not compulsory. You can just consider, like I said, consider. Then you can see there's another rectangle that says must learn tools, at least for orchestration. If I'm choosing Airflow because I feel like, Airflow is more or less like the big boy in the industry now in the orchestration space. If you're not going to use Airflow, you can use Darkstar, you can use Prefect, you can use Mage also. Now you can look at that. Then for streaming also, you would want to understand how to use Kafka for computer and big data environment, databricks, snowflakes. Yeah. Then also, you are not going to be a good data engineer if you don't know how to like containerize your environment and make sure that you can easily pick up your development environment. Like how we are doing today now, we are loading container image because yes, we have a system whereby everything works. Python works, Spark works, Delta Lake works, LakeFS works. So yes, it's just like creating virtual environments with Panda or in Python, just to make sure that yes, so all of the packages are well structured and maintained and there is no package conflict. Then yes, the CI/CD part of things, Jenkins, SonarCube, yeah. Also, like I said, Terraforms. Then there are a few ETL tools or ingestion and extraction tools you would want to know, like Azure Data Factory, SSIS, Airbyte, AWS, DMS, Fivetran, Talent, and so on and so forth. Then instead of Databricks, you can also learn how to use Azure Synapse or AWS EMR or GCP Data Proc. Snowflake substitutes, like I said, AWS, Redshift, GCP BigQuery. Then if you want to become an analytics engineer, you can consider learning DBT, then work on project. There's a link to a batch processing kind of project. There's a link to a real-time processing kind of project. There are other additional topics too. Might not be compulsory, but it's going to be like a major game changer for you, you know, these things, like building, training, and deploying ML models, Kubernetes, data visualization. To me, I feel like it's not really necessary. But you might find yourself, for those people that are going the analytics engineering, you might find yourself in a situation whereby you have to create reports, build dashboards, and all of those things. For me, I actually don't know how to build reports. I don't know. Like, if someone was asking me one day that, oh, you want to represent social data, what type of graph or what type of visual should we use for it? I'm like, I don't know. I cannot tell you what I don't know. Yeah, I know I can be funny like that too. Then also other ETL and ELT tools, like I said, Talent, Matillion. Then remember I said big data Git versioning, which is what I'll be showing us today. That's LakeFS. Then other file formats, apart from Delta Lake, we have UD, we have Icebergs, and a few other. Then yes, just be an expert or a subject matter expert in any of the topics above. Pick any tool or topic and deep dive further. Then other points you want to note, it is important to learn data structures and algorithms if you're interested in working with big tech organizations. And you can use platforms like LeetCode, HackerRank. You can use Pram for mock interviews. Yeah, you can tell your friends to Pram you or just schedule free Prams on Pram. Then also, if you decide to go the bootcamp way to learn data engineering, if one bootcamp that I know that has done well so far is the data engineering Zoom camp. I think they're starting another one soon, Sha. Then there are a few, there's this podcast by Tobias Mackey. Then you can also follow data engineering discussions on Reddit also. Yeah, it's a whole lot of stuff. I'll drop the link in the chat section. It's a whole lot of stuff. I know there'll be more questions. Yeah. Yeah, are there other ways to acquire domain knowledge aside learning on the job? Well, you can go to school and read about the domain. Like now, it's like I have a friend who is a medical doctor and delving into the data engineering space now. So he knows so much already about how they do things in the medical space. So yeah, that's really helpful to him. Yeah. Thank you. I don't know if Jennifer wants to add any other thing at this point. He's still trying to.
I was just going to say that even if you're like good with data engineering, there's always a good idea, or like you're good with the tools individually. It's always a good idea to refresh your memory. So for me, I think I'm even joining the Zoom camp, which starts on Monday, like Esther said. So it's always a good idea. I think I've pretty much covered it though. My path kind of differs a bit, like what you should learn first. But yeah, you've covered everything. So yeah.
Yeah, sure. You can share your part. Let me stop sharing my screen.
No, I said your path. I don't have it. I don't have it like laid down as you do. I think I would like maybe work on it and clean it up and then send. I just have individual stuff I've sent to individual people, and going to put it all together might seem like a lot right now. So probably I would share yours and mine with the next mail that's going out, if that's fine.
Yeah, sounds good. That's great.
Hello, Temi.
Yeah, sure, shoot.
Yeah, I was going to add a bit to what Effion asked, because I just recently had the analytics engineer interview, and they were very questions they asked were on Power BI and majorly SQL. They did ask about some data engineering stuffs like fact tables and Airflow. So I was going to add to what you and Jennifer said. Also, I asked the question on the chat. I want to know your thoughts on Mage AI and how you think it will contend against Airflow, because usually what I read online is Airflow is usually for like data engineers. That's what you see in most organizations. But tools like Darkstar, Prefect, and Mage AI are usually for like machine learning engineers, or they work more in the ML flow. So I just want to know your thoughts on the new upcoming Mage AI.
Ideally, one thing I tell people is there's no perfect tool out there. The perfect tool is the tool that makes it easy for you to get the job done. And the perfect tool is the tool that makes it possible that, oh, yes, so with this tool, I was able to deliver the job. Yeah. So my thoughts are simple. Every technology out there promises a lot. Every technology out there says, oh, these are the flaws of this other technology. This is what we are building on, all of that. I have only worked with Mage AI once, and that was when I wanted to try it out. That was when someone sent it to me, and I can say that, yeah, they have a lot of promises, and they are still in that growth stage. But for now, I would still rather stick with Airflow. Why? Because the community is super large. I know if there is any mess up or something anywhere, I can just run to the Slack channel and say, hey, tax on specific people. Hey, my pipeline is breaking. Oh, so this is the issue I'm having. Again, now, I'm not saying Mage AI doesn't also have a community, but if you look at it, like when people are saying between Python and R, which is best or which is better. As a data engineer, I don't know, I don't expect you to be using R as your major stuff, but if you look at the Python community, there's this army out there, always ready to answer a question, always ready to like, oh, there's a solution for almost everything. Because I used to tell my friends, is there anything you can't do in Python? No, I'm just playing around. Sure. So my thoughts are, yeah, as long as you're able to get the job done, that's the perfect tool. And you made it easy for me to get the job done. What matters is the destination and the delivery. Yeah, Joseph, shoot.
Hello, can you hear me?
Yes, I
Hello?
can hear you.
Okay,
yeah, I can hear you.
Thank you for the presentation. I only have one question, which is regarding the architecture you shared with us. That's the for the let's say the health application. So my concern is you didn't mention about the part where what are the possibilities that pipeline could break, and then what should we anticipate, or are we supposed to like relax? Then when the pipeline breaks, then we start thinking of how to figure it out. Hello, my question, I don't know if it's director. Should I rephrase it?
Yeah. So I'll put it this way, yeah. Even the best of the best architectures have one thing or the other that will break. So let me give you just little snippets here of a friend. Yeah, so I have a friend. this week it was working on something. It built the Docker image and everything from scratch, and it was working locally on the system. But every time it's pushing it to the Kubernetes cluster here, it's not loading at all. It's getting one issue or one error or the other. So this friend of mine, he went through it, so there was no error, nothing. At the end of the day, what was causing the issue? Git ignore file. That's why it wasn't building. Git ignore file. So for every architecture, we try our best to take into consideration what can break, what cannot break. So even, I'm just trying to let you know that with the best of architecture, anything can break. Anything can break. We can only try and say, oh, let's use this tool so that at least if it breaks, we can trace it. Oh, this is what's breaking. Can easily trace it or move to something and say, oh, this is why this thing is breaking. That's all. So yes, you anticipate it. At Microsoft, we anticipate that yes, things will break, even in production. In Netflix, in Google, anywhere you find yourself, things will break. Or have you ever bothered to ask yourself that ordinary database that you create stored procedures so that some reporting tables will be dropping every morning. You come back the next morning and boom, you see that hey, they'll start telling, hey, Michael, hey, Joseph, we've not seen our table, this, that. And I'm like, stored procedure that you've run so many times is working. Then all of a sudden something is breaking. Then you have to start tracing it. So as simple as an architecture can be, or as complex as it can be, anything can break. Just have an open mind and have this curiosity mindset that yes, you are ready to fix anything that happens.
Okay, thank you. And thank you for the example, both for before deployment and after deployment, what could happen. Thank you.
Yeah, sure. Okay, someone wants to say something. Let's see. Wow, this 4.5 different. I'm really sorry. If I knew it was this large. Yeah, Abdul, ask a question, then I think we can do something else while the Docker image is loading.
So,
yeah, Abdul, please ask a question.
Good morning. Can you hear me?
Yeah.
So my question is, I've been working as a data analyst for quite a while now. But how is that my eye on data engineering? So for someone who knows SQL and works with Python, so what are the mental model that you should inculcate when you're trying to learn data engineering? Because I've tried and learned so much. It's like there's so much thing you need to learn at a time, and you are just sometimes you find yourself swamped in technologies to learn. And so my question is, okay, learn Python. What part of Python do I need to understand? Is it compulsory I learn Flask? Is Django necessary? With pandas, I know pandas is you end up using pandas and NumPy. But like, what are the say if apart from the coding part of the writing the codes you are writing, what are the mental models you need to have or the mindset you need to have as a data engineer, or like what is going through your mind when you are having the graph? Okay, this must connect to this must connect to that. Okay, I have to have my airflow, you have to run through this, and like what are the I'm not sure if I'm making if what I'm saying is correlating, but like what are the mental models that you have that okay, oh, this is how it's supposed to be done, and if it breaks, oh, this is let's revert and let's I think I'll just kind of stop there.
Okay, so after this question, I'll take Office Song Emmanuel's question, and yeah, we would set up LakeFS environment, playground environment. Yeah. So this, so you might have to wait after that. So I think at this point, yeah, Okay, Jennifer, should I keep answering the questions or you chime in? Yeah.
Please keep answering your questions. I went to look for food.
Okay, no problem now. Yeah, so the kind of mindset or mentality you need to have transitioning from being a data analyst to being a data engineer is, I would say, number one, what's motivating you to transition? See, there is no way anybody wants to lie to you. The number one motivation why we are doing this thing is to make money. There is no, even me myself, I can't lie to you. So if you know you want to make more money and you see the figures that, oh, data engineers are making, that is enough motivation. So there are days whereby you try something 99 times, it won't work. But yes, it will still work at one time. So the kind of mindset you need to have is that it's not going to be that easy. I mean, it wasn't easy for me either, or no, any data engineering. It's not going to be that easy, but you have this curiosity mindset that you feel good when you smash some goals. Like, how would I put it? You're trying to deploy something, the next thing, you've been trying this thing for a long while. And after some time, after doing some tweaking and some stuff, you're able to deploy it. There's this joy, there's this happiness you have that you want to tell your guy, I pulled that in. I can remember when I was working at Octave Analytics and I wanted to move data from one on-premises environment to an AWS environment. And I was saying you have to use the DMS, do this, do that. Actually, I know that I pulled one massive stunt that period that even my boss too was shocked that, oh, guy, how did you do this thing, this, that? That's why I said I mess up a lot in the sense that I don't document or write out some of the stunts or some of the things I've done. So just that accomplishment that yes, I was able to move this thing using PuTTY, copy it, load the table, do all those things, set up the whole data warehouse infrastructure, like do the whole on-premises to AWS migration without having to do the normal DMS way or any of the AWS services, doing it manually. And I felt so super happy that yes, I did it. And only for me to look at one AWS paper in a few months, and I saw someone putting it in a white paper, how to do this and this and this. I felt so sad that, oh, this thing I could have just written it. So the mindset here is that you're not going to stop until you get it right. And once you get it right, we are so super happy that yes, you got it right. I don't know if that answers your question, Abdul. So it's not going to be easy, but don't stop till you get it right. Yeah.
Sort of. I think I mean technical mindset. Say how you when you were drawing the graphs, how this guy connects to this guy, how data connects to to S3 or am I should I use S3 or should I use is Redshift the best thing or is this all this
yeah, I get you. Like which technology to use for this, what do we use for this, what do we use for that? So what's happening here is that you need to read a lot of articles. You need to know what each technology does and how much it costs to set up that technology. That is the best and easiest way to come up with all these architecture things, or how this connects to this, how this connects to that, and the rest. Like now, by default, if I say, oh, want to automate a Python script, everybody starts thinking of Airflow. And there are some people that by default, if I say I want to automate a Python script, some people start thinking of Linux cron job. Some people start thinking of Lambda, and some people start thinking of Windows Stack Scheduler. I've just mentioned like 4 things we can use to automate so out of the box. Like, do you get?
Yes, I understand.
And some people start thinking, oh, a Python script, a notebook, we can put it on databricks platform and use the scheduler to run it. We can put it on Azure Synapse and run it as a pipeline. I've just mentioned some other examples. But exactly, Jenkins, CloudFormation, exactly. So like I said, what's most important in data engineering is the destination. How are you delivering the expected result? Yeah. How you do it, the technology, I mean, but some companies would be like, oh, use this specific technology. Yeah, Office on demand. Yeah, please shoot. And then we'll go
Is
to set up
sorry,
LKFS.
sorry. One more thing.
Okay.
Is scalar necessary?
Is scalar necessary? So yes, I would be sincere with you. If you are extremely good with scalar, you are a big boy, you are a hot cake, in the sense that there are some complex queries and some complex fine-tuning that you won't easily be able to do with maybe just PySpark. And I've seen people, especially at Microsoft, I've seen one Chinese guy do some crazy things with scalar, and I'm like, God, I beg. God, I beg. I just thought, God, I beg, God, I beg. If you see people that know scalar extremely well, like, trust me, they do even the worst of the worst crazy things. Like, they can literally write out their own package, their own Java, everything. It gives you an added advantage, like an extra edge compared to that. Like now, if you take a poll now that of all of us here, how many people can write scalar? You see that the figures will be extremely low. Yeah, but scalar is okay. I guess it's done. I guess it's done. I guess mine is done. Yeah, my image is done. Yeah, if it's on Emmanuel, yeah, please shoot and we'll just go straight into it.
Okay, my question is based on your reply to Nifesimi's question. So you were saying something like, yeah, every data pipeline can break at any point, right? So yeah, and I also read an article that is very important to write like tests for your code. So I'm asking, like, what's the best method of writing those tests? Because an article I read like 2 days ago, I saw someone writing like highlighting a piece of code, and GitHub Copilot automatically writes tests on that code. So is that a good idea when it comes to like writing tests for your data pipelines to prevent it from breaking? Then secondly, my other question is, what's your take on Great Expectations or that data governance tool? Is it necessary? So yeah, those are my 2 questions.
Okay. So yes, number one, it's good to, apart from just writing tests for data, whenever you code, it's good to write tests. You need to write validation also. You need to validate what you are. So you will not cook beans like they say. You need to validate the output, validate the results. Yes, so number one, it's good to write tests. And number two, as regard testing, sometimes there are some things you won't, there's no specific tool you should use for testing. There are some things you won't be able to test on the go just like that. And that is why you can take this approach of, let me build the whole pipeline first. Let me have it in my dev environment. Let me have it running. I've tested it for like, 2-3 days, or I've tested it. I've done like 50 runs in my dev environment. Let me now create a PR and push it to production. That is also testing too. So what does that mean? You've done all of your nitty-gritty. You have it in an isolated dev branch or dev environment, and you're now pushing it to the main branch, which is why we're having this workshop this morning, which shows how to do that with a tool called LakeFS. And then my take on Great Expectations. Great Expectations is an extremely great tool. Like, you can literally write schema enforcement and all those things against ordinary data lakes. Yeah, so it's like, I'm trying to do my own Delta lake from scratch. In the likes of Great Expectations, you can write your own data quality test, do some assertions, all of that. Yes, it's a great tool, actually. It's a good tool. Yeah. Then also there are also some other tools for data governance, like I'm just saying, yeah, and a few other tools. The problem is just that some of all these things are expensive. Some of all these things are expensive. Let me just give you a little insight to what I know. For some of our own tools at MS, people wrote them from scratch. People built them from scratch. That's why they're internal tools. Yeah. Abdul, you are still raising up your hand. Unfortunately, I won't be able to take your question. The other person, I was unable to take the person's question. I don't know. I think he's at Desoji or so. I was unable to take the person's question. Yeah, then the last command I want us to run, I'll put it in the chat section now. So we will just do that and and set up Lake first, then take another questions. Yeah, we still have some time. Let me share my screen. Okay. I don't know if you all can see my screen already, though.
Yes, I can see your screen.
Yep. So I'm posting that. I'm running it now. Okay, mine looks good. And the last thing I want us to set up is the Lake FS playground. So I would drop the link to set up the Lake FS playground in chat section. And it's opening. Let me do this. So it's a playground environment. It's going to give us like an S3 bucket and set up all the necessary tools just for us to see how we can do Git versioning in a big data environment, how we can test our data pipelines or test the results of our data in isolation without affecting production data. So for this, I'm going to use this email. Yes, I've done that. So immediately I click on that link, I'll type in my email, and next thing is I'll go to that mail. Okay. I want us to see. Okay, I think this looks good. So let me come to the mail. Yeah, you can see Lake first playground provisioned, and you see get started by following this link. So I'll click on the link. Yes, so what you can see here is I have my playground URL, I have my Lake first access key, I have my secret key, and this expires in the next 7 days. And yeah, the next thing I'll do is I can say take me to my playground or go to the playground URL. So what this does is that it provisions an extra bucket for me with the whole Lake first environment. I can say take me to my playground. Okay. Yeah, so it's going to ask me for my access key ID and my secret key, which is what I have here. So I'll copy my access key here and paste it here. I would also copy my secret key and paste it here. Then I'll log in. I'm not going to save this one now. So as you can see, automatically, let me wait a bit. I don't know if some guys have done this. Yeah, if you are in this page, just type yes in the chat section. So I would go on with explaining this. Okay, I think I can see some yes already. Okay, cool. Yeah, I already have 2 people. A lot of folks would follow through with the recording because we are running behind schedule now. So guys, what you can see here is to some people this looks like the normal GitHub, but what you can see here is the GitHub for my data environment. And what you have here is my first repo, and a repository in this sense contains my data set, including the revision history, local grouping of related data. And in this place, in this repo, I can manipulate data safely without destroying the data object, underlying objects, and with the ability to roll back my changes. So I'm going to show you something. If you look at these guys, let me go back. I don't want to just come back immediately. Yeah, so if you look at these guys, automatically look at this storage namespace. This is the location to an S3 bucket. So it's like instead of seeing your normal S3 bucket instead of seeing your normal S3 bucket UI in your AWS console, you have decided to provision LakeFS as an admin for your S3 bucket so that you can roll back changes. You can create your dev branch, your main branch, your production branch, like create different environments, perform operations on your data without affecting the data. So now let's go straight into it. So I click into my repo, and next thing you can see a sample notebook, you can see sample data to work with. You can see what cities, database population. This is a delta table, I presume. Okay, it's not a delta table. Yeah. You can see what city database by population and all of that. So now is the next, now is the next so we are going to do this now. So let me just explain this further. Guys, remember when I said that if you look at it as a repo, imagine if this main branch is my production branch now. All this data here like this now. I can create a new branch and call it Temi's branch. And I'll be able to work on the sample data or the World City database population data without copying it out of this place, without copying it out of the S3 bucket. It's still in the S3 bucket, but I'm doing all sorts of operations to it, and I'm not messing up with it. So that's what I'm trying to let us know here. So now what I'm going to do is we are going to create a new notebook from our Docker container image. And yep. Let me paste that in the chat section. So we would see. Okay, so I'm trying to paste this in chat section. So I'll say something. I'm gonna put this. Yeah. So we're going to go to that address now that I believe by now we should have our Docker image running. So if you come to Docker, your Docker, you see that you have LakeFS, Spark, Python container running already. Like I said, it's running on port 40888. So yeah, it's running. You can see it's screen here. Just confirm you also have the same thing. And next thing, I'll come back to the chat section and go to that address for my browser. Where's my browser? Let me use this one. Yeah, so I'm starting the Jupyter Lab. Automatically, in this Jupyter Lab, I have Airflow, I have Spark, I have PySpark, I have Delta Lake, I have LakeFS, and I have sample notebooks. I already have a ton of things configured already for this workshop. So what I'm going to do is I'm going to make it quite fast and easy because we're running behind schedule. We have our terminal. So if you have this, can you type yes in the chat section? If you've been able to set up, if you've been able to get to the Jupyter Lab page, can you type yes in the chat section? Okay, the last 2 minutes. Yeah, sure. I can recap the last 2 minutes. Yeah. So I said that immediately you are done downloading and setting up the Docker container, the next thing you will do is you will build it and just and run it. You will build it and run it. So I dropped something in chat section for you to run it. Oh, the link is asking for a password and token. Go to your email address that you typed here. If you look at this place, when you came to this place, you typed in an email address. So go to the inbox of that email address and click on, when you click on create my playground, you go to the inbox of that email address. And when you go to the inbox of that email address, you will see LakeFS playground provisioned. Then you see get started by following this link. You click on this link and it brings you here. It brings you to your playground environment is ready to use. So just click on take me to my playground. When you click on take me to my playground, it's going to ask you to put in the access key and the secret key. So you can just copy those two things and put them in. Then it brings you to the repo here. You are going to see my repo here. Then you can just click on the my repo directly. It brings you to the Git, to the data Git UI interface for your S3 bucket or your object storage. Let me see. If you have been able to get to the Jupyter Lab side, just type yes in the chat section. We've been able to set up LakeFS Playground. We've been able to load and run the Docker image, and you've been able to visit this address. Can you type yes in the chat section? Anyone? Benjamin, I don't know if you got what I did. So, okay, Blessing has a question. Yeah, Blessing, can you come?
Yeah, so the issue that I'm having is with the last link that you sent. So it takes me to a page and it's asking for a password or token for Jupyter. So I don't know what password should be there.
Oh, it's asking for a password or token for Jupyter, right? So you probably didn't run, give me a minute. You probably didn't run the password and all of that. Let me share this with you. You won't be able to get the password. Let me share the last. Share this with you. Okay. Okay. You ran this, right? You ran what I just pasted on the chat section,
Yes,
right?
I did. Yeah.
Okay. You ran it where you set up the Docker image inside the same folder or directory, right?
Yeah.
Okay. Can you stop it in your Docker desktop and yeah, can you
Run it
stop it
again.
in your Docker desktop and run it again? Yeah.
Okay, I'll try that. Thank you.
Yeah, Benjamin says, I guess there are commands to be run before running the Docker run. Sorry, I was 10 minutes late. Yeah, the command to run before the Docker run, they're just two commands. So I'll paste them again in chat section. So we don't take time. That's the first one. And the second one is the one that builds the Docker image inside our directory. And the last one is the Docker run itself. Then after that, you open Jupyter Lab. So is there anyone that's been able to open Jupyter Lab? If I can get one person, I think I am good. I think I'm good. We can always follow through with the recording. We are running behind schedule at this point. Is there anyone that's been able to open the Jupyter Lab environment? Anybody? Anyone at all? Blessing, you have your hands raised. Is there anyone that's been able to get to the Jupyter Lab environment? Wow. Okay, if you are following me, can you type yes in the chat section? So maybe I can just get one person to the Jupyter Lab environment, please. Building the Docker container image. I said the Docker container image is about 4.5 gig in size. So it means you'll be downloading 4.5 gig worth of data. Oh, Office on the manual. Oh, cool. Makes sense. Chi Dozier got sent. Okay. Let me just get one or two people. Oh, Blessing, you too. Nice. Nice. Makes sense. Okay. So I have two people that have opened the Jupyter Lab environment. That's great. And okay. It's fine. Yeah, so I already have like a notebook to simplify things because I figured that time might not be enough. We'll just be changing a few configurations there. And let's open the Spark demo notebook. Yep. Spark demo notebook. So what we are doing here is we're integrating LakeFS with Spark and Python. And the use case here is just like, I don't know who asked this question today. It was asking about data testing and all of that. Yeah, so these use cases, we are going to be doing some isolated testing in maybe Emmanuel's dev branch or my dev branch. Then I'll show you how you push from dev to production for a data environment without messing up the data in production. So it's like you're working on the data they already have in production, you're doing some extra transformation and so on, and all of that, but you're not messing things up. Okay. Yeah, we've already done the prerequisite, which is the notebook requires connecting to LakeFS server, spin up LakeFS quickly, there are links and all of that. So now we are going to put in all of the LakeFS credentials we got from the LakeFS playground. Okay. So to do that, if you look at it, the playground URL, I'm going to copy it and come back here. I would replace this with the playground URL. I presume someone is following me. For those following me, please feel free to stop me at any point. And I'll come back here, copy the access key and replace it. Same thing for the secret key. Okay. Yeah, then also I need to change the storage namespace to the name of the S3 bucket itself. So if you look at it, the name of the S3 bucket itself would be the username LakeFS Cloud. That's an example. So what we're going to do is okay. So I'm going to come to my LakeFS UI. I'll click on repos. Then I took this. Yeah. Yes, so I'm going to copy all of this. And once I do that, I'll come back here and pasting it. So this storage name location is just referred to store every single thing about the repo. So I can see my repo and just call it Temi's repo. Okay. Yeah, so if there's anyone that's gotten to this point, I need a yes in the chat section. So I'll be sure that I am not going too fast ahead of some folks. Okay, blessings with me. I need two more people. Sorry, please give me a minute. Okay, apart from Blessing, is there another person? Emmanuel, are you in the same place with me? Oh, okay, Emmanuel is there now. Okay, makes sense. I'm going to come back and just continue from where I stopped earlier. Okay. Yeah. So the next thing is, sorry, please give me a minute. Yes, so I'm so sorry about that. Like I had to quickly attend to a call. So if you look at this notebook, what we have here is if you look at this cell, we have the versioning information. That's we have the branch that we are cloning data from. We have the new branch we want to create, which is the experiment one branch. We have the file name we are playing around with, which is LakeFS test CSV. We have new parts. Then we have also configured our LakeFS Python client. Then we can also change the name of the repo also if we want to. I've done a couple of things here to actually make it very easy to work with and to perform this little experimentation. So what's going to happen is I am going to run all of this now. Yeah. So from here, what I'm doing here is I'm setting the LakeFS endpoint, the access key, and the secret key. So what's happening is that we have a cloud object storage, and we are bringing Git version into the cloud object storage, apart from using just Delta Lake. So that means I'm using Delta Lake to manage the data, and I'm also using LakeFS for Git versioning also. So I'm going to run this. That's the first cell. In this second cell, I'm setting my storage namespace. So if you look at it, if you go back to your LakeFS UI, you see that this is the location to an X3 bucket. And I just copied this and I'm pasting it back in the cell. So once you do that, I'm going to run that. And this is where I'm setting all of the versioning information, the new branch I want to create, and all of that. So the next thing is the LakeFS Python client. This is where I'm setting, stating all of my objects of the LakeFS Python client, importing it. And yep. And finally, I can change the repo name. I can change LakeFS repo name. It can be an existing repo, or I can provide a new repo entirely. So I will change this to, let's say, Temi repo. Yeah. Once I do that, if this rep, what I'll do now is I want to create this new repo called Temi repo in my LakeFS environment. So give me a minute. So I want to create this repo called Temi repo in my LakeFS. If I go to my LakeFS environment, as you can see, I have just one repo called my repo. So I'm going to create a new repo for us to work with. You can call it your own name or whatever you like. So I'm going to do that right now. And by the time we go back to the LakeFS UI, you will see that it has created a new repo called Temi's repo. And the next thing is actually to upload a file. That's upload the data we want to work with. So I'm going to refresh this page to show you the new repo, which is what? Temi's repo. So I created this few minutes ago. So a repo is like a project. So if you work in some companies whereby they have usage data, they have HR data, or they have different use cases. In some companies, they have loan prediction as an analytics project. They have customer retention as another. You can have different projects with different data in your lakehouse as different repos. So that we are making sure that the data that belongs to project A is not clashing with project B, is not clashing with project C, and all of that. So the next thing is you can see this is a totally empty repo. I can decide to upload my data directly. I can decide to choose a file and upload data directly. So I can decide to choose a file and upload data directly, or what I can do is I can decide to upload the data with code, with Python. So let's do this. Yep. So I would I'm going to try to upload it with code, and I also do one of the data with UI also. So now you can feel free to stop me at any point in time. So I've uploaded data from the local directory within Docker image. I've uploaded data. You would see data here. So if I come here and I refresh this, you should see data now at the very least. Yeah, we already have our data here, which I uploaded a few seconds ago. As you can see, it's showing the CSV file that I uploaded. But if you come back to commits, you will see that the only commits I've done so far, I know these are some software terms that some people won't understand. The only commit I've done so far was the commit of creating a repo 2 minutes ago. If I come to uncommitted changes, you will see that I've uploaded this data, but I've not committed it. So in actual sense, I've uploaded it. If I don't commit it, you're not going to see it in the S3 bucket or in our lakehouse environment. You're not going to see it in the bronze layer. So I want you to see each. Yeah, if I create different folders now, or let's say I'm uploading an object now, let me just do this. Yeah, let me upload from the UI. So I want to choose a file now. For this file, I want to choose, let me just upload a typical JSON file or something. Yeah, let me upload this JSON file. Yeah, sample patient to JSON. I can decide to say, let me upload it to bronze layer /JSON. I've uploaded the file. I've uploaded my data. Inside the folder, inside my bronze layer, you will see sample.json, but I've still not committed it. Uncommitted changes. You can see it here. So I can also still go back and let's say I want to have my silver layer. Yeah, let me choose another file, something pretty much simple. Yeah, let me choose something of a different file format. Let me choose something, yeah, entirely different. Let me choose a PDF file and say silver layer and upload this also. So I just want you guys to know that the whole lakehouse paradigm, just having 3 sections and saving data in Delta format or iceberg format or UD format and keeping metadata about the data, then adding versioning to it also. So I have my bronze layer, my silver layer. I'll just do this once more with another file, maybe a video this time around or something, a kind of file format. Okay, let me see. That's quite a large video. Yeah, let me upload a video this time around. Yeah, I can call this bronze. This is going to be the gold layer. Let me call this video file. I just want us to see how we can work with different file formats within the lakehouse. Yep. It's going to take some time. It's quite large. Yeah. So if I still come back to uncommitted changes, I have my gold layer, bronze layer, silver layer files. I have the CSV file I've uploaded, I've pushed, but I've not committed these changes. Do you believe that if I don't commit these changes, this data won't be there until I commit the changes before this operation is finally accepted? So yeah, let's continue. Sorry, I can hear some background noise. I can hear some background noise. Okay, thank you. Yeah, then another thing I would love to show us is that you can import data directly from your S3. If I come to objects and I click on import, you can import data directly from any of your S3 buckets or from somewhere, from any of the cloud object storage that is S3 compatible. So you can import from, specify the name, and you can specify the destination, which is this. Yeah, you can specify the destination also. And I mean, it's pretty much quite easy, the same way you do for commit messages in Git and all of that. Okay. So now is the time to, let's commit these changes and attach some metadata to it. Then let's just talk about Lake first, do some transformation, and we are good to go. Oh. Okay. So I am here now. I'll commit these changes and attach some metadata to it. Yeah. So you can see I added the commit message, added my first file using Python API and all of that. So if you go back to LakeFS and I refresh, wow, running bench schedule. I'm so sorry. I'm really sorry. Really sorry. And I come back to uncommitted changes. You see that there are no more uncommitted changes. And if I come to my commits, you see that I committed a ton of files and I said added my first file. Added a ton of files actually. So let's just go back straight to the notebook and I would walk us through. You can configure LakeFS to work with Spark in two different ways, using an S3 gateway or a LakeFS specific Adobe file system. And you can do that here by putting your LakeFS access key, LakeFS secret key, the endpoint, and the style also. So we are going to do that now. If we want to, yeah. Okay. So I'm going to run this. The next thing, you can read data from S3 directly using the S3A gateway. So right now I'm trying to read the CSV file that I uploaded. So if I do that, you're going to see the CSV file, the data that I uploaded. That's the LakeFS test.csv. It's going to show it. Yeah, just simple data. So now let's experiment. So the experiment here is that I want to play around with that data, creating a new branch. I can call the new branch my dev branch or whatever branch I want to call it. You get now. So what I'll do is I can list the repository branches using the LakeFS Python API. Yep. Yeah, so you can see right now I have just one branch, which is the main branch. So now I want to create a new branch and yeah, I will call the name. Yeah, so I want to create a new branch and I can decide to give the name anything I prefer. Yeah, it's up to me. I can call it new branch or I can call it experiment one. If you go back up, you see that we already specified these things up. In terms of versioning, new branch is called experiment 1. So instead of experiment 1, I can say Temi's branch, Temi's dev branch. So I can run this, then come back and create a new branch. So if I come here and I click on create new branch, you see the branch has been created. If we go back to Lakefest, go back to Lakefest, and I come to branches, you see I have 2 branches now. I have my main branch, which is my production branch, and I have my Temi dev branch. What this means is that the data I have in the S3 buckets normally, or in my lakehouse, is available to the main branch, which is the production branch, and is also available to the Temi dev branch. If I come into this branch called Temi dev branch, whatever I do to this data in this environment has nothing to do with the production environment. It's not going to break. It's like testing in isolation, actually. It's not going to break, and it's not going to affect what's in production. So I can't really remember who asked that question the other time, but this is to show you that you can do isolated testing with Lakefest. Yeah. We'll probably talk about Delta Lake and Airflow some other time, but if you look at the Jupyter lab UI, you see there are some other notebooks that are already added there for us to work with and just experiment with. So now what we are going to do is we are going to partition the data and write to the new branch using S3 gateway. So I want to partition the data by the very first column, which is _C0. Yeah, I am going to do that right now. Let me just rush over this. It's 12 p.m. already. Okay. Okay. I know some people will be meaning to ask questions. How do they implement this and all of that? Yeah, then next thing I want to, yeah. So what I'll do is I'll take the difference between my main branch and my new branch for us to see the differences and to show all the uncommitted changes in the branch. If you notice, my data, which is the Lakefest test _c.csv, I've partitioned it by C0. So I am looking at the differences right now. And from what you can see here, these are all the uncommitted changes. I've partitioned the data by the C0 column. You can see that it's showing us that data partition is a success. And let me come back to Lakefest, reload, and just show us for ourselves. Show us for ourselves. Okay, so can we all see partitioned data? Inside partition data, partitioned by this column. And like I said, everything you do is taking the log. So this is one of the log files here. So if I come to uncommitted changes, you see that the partition data I created is in which branch? Temi's dev branch workspace. Is not in the production branch or my main branch. So this is me doing data manipulation with data in an isolated space without having to copy data from one place to another. And yep, okay. So at this point now, I want to commit the changes and attach some metadata. So I'll just add a message. I partition the CSV file. I'm sorry, I'm rushing through this. And by the time I come back and I click on uncommitted changes, you shouldn't see anything again. Let me just refresh. Remember, we're still working with the dev branch, Temi's dev branch. Wow. Okay, yeah, there are no uncommitted changes. If I come to commit, you see in Temi's dev branch, I've created a partitioned CSV file. But if I go to the production branch or the main branch, there's nothing like a partitioned CSV file. I don't know if we are seeing it. So if I come to objects now, on my main branch, there's no partitioned CSV file. But if you look at my main branch, which is my production branch, But if you look at my dev branch that I created as a data engineer, there's a partitioned data. Yeah. Can we all see the difference now? Yeah. So this is one of the isolated testing you can do in a lakehouse environment without messing up with what's working in production. Then afterwards, I can show you guys the differences between the new branch and the production branch. I would run that. As you can see, it's showing us that there is a partition data folder, then there's the partitioned CSV file itself. Then I'm done experimenting with the data. I've created the dev branch. I want to merge my dev branch into my production branch now. So what I'll do is I'll delete the new branch if the experimentation fails, or merge the new branch into my main branch, which is my production environment, if the experimentation succeeds. So I would delete it if the experimentation fails, or merge new branch into main branch if the experimentation succeeds. That's atomic promotion to production. So we can do any one that we are interested in doing. Yeah, I want to merge into production. So I'll run this cell. I wouldn't delete it. Yeah. So right now I have merged my dev branch into production. Yeah, so if I come back here, if I come back to repos, I reload. I'm so sorry for taking our time, but hopefully you'll be able to watch the recording and just follow along, then go through other notebooks that are in the Docker image. Okay, Christian should act up now. Okay, yeah. So right now, I'll click on my project environment systems repo. As you can see, I have meshed the changes from my Temi's dev branch into production environment, which is the main branch. You can see the partition data there. You can still see my Temi's dev branch. I've not deleted this branch yet. I can decide to delete this branch since I've meshed the changes. Yeah, so if you look at it, you see that if you meshed, yeah. So I can check the differences between the new branch and the source branch. You see there will be no difference at all. So right now you can see it's not returning any difference. It's not returning any change at all because dev branch and the production branch are practically the same thing. So I can also roll back changes. Yeah, even though I have meshed my dev branch I've meshed the changes of my dev branch to my production environment, I can revert it back and say that, okay, yes, I don't want the transformation I did in my dev environment. I don't want it in my production anymore. So what I'm going to do is that I'm going to revert back that commit ID, just as how we do now in normal software engineering. Yeah, and you can also do some of all these things from the UI. I think I should show us that. If I come to compare, you can see there's nothing to compare. Why? Because oh yeah, there's something to compare. Let me change main and compare main to Temi's dev branch. There's no changes because they are practically the same thing. Assume there was a change now, I could click on merge and decide to merge it from the UI also. Yeah, so let me go back and I'll just show us how to revert the change that I have in my production branch back to what it was originally. So okay. Okay, so I want to do something very, very funny. Yep, so I want to do something very funny. So right now, I want to revert the changes, and this is the beauty of it. I would go get the commit ID for all of my commits. So if you come back to, let me switch to the main branch. If I come to commits, if you look at the different commit ID of all these commits I've done, right from the time of creating the repository, to the time of adding my first file, to the time of creating the partition CSV file, to the time of merging Temi's dev branch into main branch. Let's say I want to revert it back to the point of adding my first file, and I don't want the partition CSV file. I am going to copy this commit ID. Yeah, I'm going to copy the commit ID and I'm going to revert it back. Yep. So once I run this, it's going to revert back my changes, and we'll see how I have taken production back to where it was before without any hassle or without any hassle or without what do you call it? Yeah, without any hassle actually. Okay. So I will just refresh this and trust that and take a few more questions. I'm so sorry for taking our time. I guess the 10 minutes we used still waiting for a few other folks is what we have used practically here now. Okay. Okay. This thing should load, and I guess we are good. Yeah, so the changes are reverted back. Yeah. If I come to commits, yeah, if you notice, I've reverted back the changes to the way it was before. Yeah, as you can see in my commits, I've reverted back the changes to the point where I added my first file. Yep. If I come to Temi dev branch, when I came to Temi dev branch, as you can see, in Temi dev branch, I still have all these files, but in my production branch, I've reverted it back to when I added the first file, the first partition file. I reverted back to a previous commit. So what I've just shown us is with LakeFS, you can all sorts of experimentation with your data in an isolated environment and still be able to revert back or still be able to go back to a previous commit or still be able to go back to this particular point. So let me just do something once more. Let me come back to mesh Temi branch into main. Yeah, I'm going to take it back. Yeah, just for the flex of it. I would run this by the time I refresh. Yeah, by the time I refresh, you see that yep, data is pretty much back to normal or how it was before. Yeah. So as you can see in my main, there's literally nothing now. So let me just refresh. Yeah. And show us this. Wow. At this point, I think I can take questions. Yeah. I'm so sorry for taking our time. And I'm sorry for rushing it at the end. Oh, I know some people are still trying to like put one or two together or put two or three together. Yeah, so I can take questions and I'll let Jennifer chime in. There are a few other things you can do in the environment, in the Docker, in the Jupyter Lab UI. You can set up CI/CD for your data environment using LakeFS hooks so that once you create some merge, you can run some automatic testing or code coverage using the LakeFS hooks. You can also play around with the LeFlow notebook there, Delta Lake notebook there, and a few others actually. Thank you very much. Wow. Hi, Jennifer. I guess I'm done. I know this might have
Oh my.
been too high or too much for a few folks. I'm sorry. I'm sorry.
Thank you so much. At least I would listen to the recording again, and like everybody can get to listen to the recording again and follow up or follow through. But this has been really, really insightful. So give me a minute, sorry, I'm just walking upstairs.
It's fine. It's okay if you don't understand everything right now. Just take your time.
So, this versioning, this isolated testing, does it come with all other product of lake houses or just lake FS that has this feature?
It's Lake FS that bring the whole gate capabilities to the lake house. So it's not, yeah, for the managed platforms, you have this naturally. For the managed platforms, you have this naturally, like for the databricks environment, they do this for you naturally. This is an open source implementation. So that's why we're using LakeFS for it.
Okay, I'm back. So hello everybody. Thank you so much for staying. The class stayed or went a bit longer than expected, 15 minutes. And is it ideal for running multiple experiments? Temi, I guess that's you.
Yeah, sure. You can run multiple experiments, ideally. You can run because the data is just there. You're just playing around. The data is just in one place in probably your S3 bucket or cloud storage. You're just doing all sorts of, like I said, if you have 5 data scientists, they're doing all of their data transformations and manipulations in isolation.
So thank you guys for staying till the end of the course. If you have more questions, you can definitely reach out to Temi. I will be sending his details alongside the email that I will send you with the recording. Hopefully, the idea is to get it uploaded on YouTube so everybody has access to it. But yeah. Thank you so much for staying to the end. I'm now going to stop recording